This is a brief introduction to C#. It clarifies frequently used terms and gives you some basic knowledge to help you get started quickly. Let's begin by clarifying the difference between expressions and statements. Expressions evaluate to a value. Here are some examples. 4 plus 5. That evaluates to 9. My variable times your variable. That evaluates to the product of the two variables, provided they were numbers. Hot plus dog. Here we use the string concatenation, and it evaluates to the single word hot dog. Statements do something. They're terminated by a semicolon, or they include a code block. Let's look at some examples again. All of the three examples do something. The first one assigns a value to a variable. The second one writes hello world. And the third one returns the string even if the number modulus 2 equals 0. Notice that statements can include expressions. And the first statement, for example, includes the expression 4 plus 5. Expressions can include expressions too. In the third statement, for example, we have a Boolean expression. Boolean expressions are also called conditions. In this particular case, the left operand, number modulus 2, is also an expression. Let's have a look at some types. C# has a number of predefined types in the system namespace that are also known as built-in types. On first sight, they might seem like C#'s counterpart to Java's primitive types. However, there are some differences that are worth mentioning. Java has 8 primitive types. C# has about twice as many built-in types. All primitive types are value types. Most of the built-in types are value types, but there are reference types too. Java's primitive types have neither fields nor methods. C#'s built-in types have both fields and methods. The MSDN website includes a list of the built-in types. Let's take a moment to look at it. In the left column, you can see keywords. Those are aliases of the predefined types listed on the right. There's no performance benefit of using one over the other. However, using aliases makes your code more concise and easier to read. You can find a counterpart for each of Java's primitive types. Integer, long, and short also have an unsigned version. You can see it here on the prefix u. Notice that byte has a signed version because byte is by default unsigned. There's also one additional number type. It is decimal. Decimal is more precise than double, and it is used to represent monetary values. All the types we have mentioned so far are value types. The built-in types also include two reference types. Those are string and object. There are two subsets of built-in types that I want to point out. One are the simple types. Those are all built-in types that are value types. So it's all the types we looked at except for string and object. And then the integral types. Integral types are the whole number types. You can see byte, short, integer, long, and the signed byte and the unsigned version of short, integer, long. And also there's character. Each character has an underlying whole number value, and in C# it counts as an integral type. Let's have a look at variables. C# is a strongly typed language. There are no implicit variable declarations. Variables must be declared explicitly. Here is an example. I could have a variable I1 of type integer and then I assign the value 1. Or I could have a variable I2 of type integer and then the same statement assign the value 2. However, if I try to assign the value 3 to I3 and I never specified what type of variable I3 is, this won't compile. Variables must be assigned before they can be used. So here I have a declaration of a variable s of type string, and then I try to print my s, but s has never been assigned a value. So that's a problem, compile them error. There is one exception, and this is the out parameter. The out parameter has the keyword out both in the method declaration and also in a method call. It allows us to pass a variable that has been declared but not initialized. The out parameter guarantees that the parameter passed will be assigned before it is used in a method and before it is returned. So in this case, our method is try_parse. It's a static method of our built-in type double, and it checks whether the string 3.14 can be parsed to a double. In our case, this is possible, so number gets assigned the value 3.14, and when we print number, we'll print 3.14. Now let's just assume there would have been a typo or some other reason to have a p there, and at this point the string 3p14 can no longer be parsed to a double. What would happen is the following. Inside the method, they check, can the string be parsed? They realize, no, this is not the case. Number would get assigned the default value for double, which happens to be 0. And in this case, because there's this if statement, nothing gets printed, because we only print if try_parse succeeded, if it returns true. So if 3p14 cannot be parsed, try_parse would return false, nothing would be printed. There's something else that I want to point out, and those are implicitly typed local variables. This is a special feature of C#, where local variables are given an inferred type of var instead of an explicit type. Important to know is that the type is known at compile time. Using var instructs the compiler to figure out the type based on the value or the expression that is assigned to the variable. So here's an example. I could say var v1 is 7. So in this case, compiler figures out 7, that's an integer. So v1 is really a variable of type integer. Var v2 is house. Compiler realizes house is a string, so v2 is a variable of type string. If we would say v1 gets assigned v2, this does not work. Both are declared as var, but this doesn't mean I can assign it to each other. v1 is an integer variable, v2 is a string variable. String cannot be implicitly converted to an integer. If I try to call a non-existing method, I would get a compile time error because this is not possible. Here is a brief look at operators. You can see we have the same operators that were used from Java, and I want you to take a moment and figure out the value and the type of the following 4 variables. Please pause the video, give yourself a moment, and when you're ready, press continue. So here are the solutions. First, we have integer division, 5 divided by 2, that's 2, integer division. My result of the expression on the right hand side is an integer, so v1 is an integer. 5.0 divided by 2.0, that's a double division. The result is 2.5 and v2 is of type double. 7f, f stands for float, that's a floating point literal, divided by 2, that's 3.5, but is 3.5 the floating point number? So v3 is a floating point variable. Here we have 7 modulus 3. Modulus is the remainder operator. 7 divided by 3 is 2, remainder is 1. 1 is of type integer, which means v4 is of type integer. Here we have a selection of primary and unary operators. We have the dot operator to access class members, parentheses to invoke a method, rectangular brackets for array index, increment and decrement before and after, and we have a new operator to invoke the constructor and create a new object. We have the logical not, and we also have the cast, where we have the parentheses and some type specified in between. Here we have some binary operators. Again, this is only a selection and not a complete list. We looked at the first row already, the relational operators like less than, greater than, equality, not equal, the and the or operator. They both have short circuiting, just like we are used to from Java. Then we have the assignment and also the compound assignment operator, also analogies to Java compound operators. We have the lambda operator, that one is new, and we're going to spend quite some time studying lambda expressions. As a heads up, those are anonymous methods. And here we have the null coalescing operator. We're going to look at that in connection with nullable types. Last but not least, I want to look at some control statements. With the same three main categories that we're used to from Java: sequence, selection, repetition. Sequence means that we execute one statement after the other unless otherwise specified. Selection has the if and the if-else statements, just like we have them in Java. And for repetition, we have the for, the while, and the do-while loop, just the way we use them in Java. In Java, we also have a switch statement. So do we in C#. However, they work a bit different. So when you want to use the switch statement, make sure to check out the differences, especially in regard to fall through. We also have a for each loop in C#. It works very similar to Java. However, instead of the keyword for, we use for each, and instead of the colon in the middle, we use the keyword in.